Okay, sixth grade. So today I can't be in class, and we're going to look at solving equations. Number 9. This is in. I'll show you here. This is in this packet. It's go to the beginning here. This is in the algebra number 1 packet, basically. Let's see if I can get it to the beginning. So it's in the algebra number 1 packet. That starts with lesson 6. We've done 6, 7, and 8. We've already gone through all of these. So we're going to take a look at lesson 9. If you missed those other lessons, 6, 7, and 8, then I will put videos up of those this week. But for now, I just want to get to the next lesson. Okay, so let's get started here. We've got this all going again. So this is about solving an equation, and so solving an equation we're going to be using the inverse operation, and that just means to do the opposite. That's really all you got to keep in mind. Don't want to make it too complicated. So that's what you're going to see today, this thing called inverse operation, and basically what that means is you just do the opposite. Math operation, like if it's addition, you do subtraction, multiplication, you do division. So the opposite, and when we say operation, we mean math operation. And you just do the same to both sides of the equation. Same to both sides of the equation. And that's really those are the basic principles that you need to know. So if you can do those things, keep those 3 things in mind. Inverse, that means do the opposite. Really just 2 things, because those 2 go together. Then you're going to be in great shape. Okay, and then if you look through here, you'll see it says the same thing. It tells you the definition of an equation. Equation just has an equal sign. And then it's going to give you that in order to solve, down here it says use the inverse. Okay, and then the goal is to get the variable by itself. So you're trying to get the variable by itself, and that way you solve for whatever the variable is. You might say, well, why are we doing algebra? Well, this is the math that just makes stuff work. This is how you solve the problems of how thick to make the cover on your computer. How much time is it going to take you to do the 3 tasks that you have to do today? How much money are you going to make if you start that small business? So this is just the math that makes it work. It's like the tool in your toolbox. So let's just get through a couple of examples here. The first one, okay, it says Agatha earns $8.25 per hour. Okay, at the movie theater, she earned $66 one weekend. How many hours did she work that weekend? Okay, so if you're owner of a small business and you're trying to go back and figure out what's going on with who you paid, this is what you can do. You can use an equation to do this. So the first thing says write an equation to represent the problem. So that means you're going to have a variable. Okay, and it says $8 per hour, and we want to know how many hours. So that's our question. So we want to know hours. So we're going to let h equal hours. Makes sense, right? Okay. So just come down here and look. It says, so the equation would be that she would have, and we also know she made $66 overall. So here's your equation. It just tells you right here you've got $8.25 per hour. So that's times h. And altogether, she made $66. And you might think, well, I don't even have to do a variable to do that. I can just divide and make that work. Well, that's true. But knowing how to use a variable then makes this much more powerful for you. So that means you can solve all kinds of problems later. You can put in all kinds of types of hours that somebody worked, and typically, like maybe you'd have this running in on your laptop because you're doing some work for somebody. Okay, or you could just use this if you have your own business, like my kids. They have a couple little businesses that they do, and they could just work it on paper. Okay, so what do you do? All right, so bottom line is number one, you're going to solve for h. So look how you do this. I'll come over here real fast. Remember we talked about those three things we're going to use. So here we go. We have 8 and 25 cents. Now instead of times, we can just put h because that means to multiply. When you put that together, equals 66. So the first thing was, well, what's the inverse operation? You know, sounds fancy, sounds tricky. No, it's not. Look at the 8 times 5. So right there on the 8 times 5, you want to get the variable by itself, okay? Because that's what you want to find out. It's just another way of finding out how many hours, okay? That's all you're doing. Well, what's going on here? Well, you're multiplying 8.25 times h. You're multiplying it. So the inverse means the opposite. So you're going to do the opposite. Okay? That means you're going to divide. So what you do is you're going to say, okay, well, I'm going to divide, and I'm going to draw a division line here. That's one way to show division. Okay, I could also just put division. I could have just used the division sign like over here. Either way, it doesn't matter. So now you're going to do the same thing that you do to both sides of the equation. And the reason you do the same thing to both sides is because an equation is just a teeter-totter. Super easy. Okay? See, there's the equal sign. We'll say that is, here's our teeter-totter. Over here, you've got this guy sitting, and over here, you've got this guy sitting. So this is, over on this side, you've got 8, this part of the equation, 8.25h. Okay? And over here, you've got 66. And in the middle, you've got this equal sign, which means the teeter-totter is perfectly straight. Perfectly straight teeter-totter. So if you divide this side by 8.25, then the teeter-totter won't be even. So you just come over here and divide this side. So that's all it means. Keep the teeter-totter the same. Keep it even. That's all we're doing. Don't make it complicated, okay? So here's their example, and then we'll just kind of take a little look. They use the calculator over here. So 8.25 divided by 8.25. Anything divided by itself is 1, so this just becomes h. And then you can use your calculator and you can do 66 divided by 8.25. Okay? And that's what they did down here. And they figured out h equals 8. And that's it. That's all we're doing. Then you can check it. So let's look down here. They checked it, okay? How you check it? Well, you just go put back in what you said. So you said h equals 8, right? So look what they did. They copied it. Remember how you just copy? They substituted, like Mrs. Van Houten has taught you. They put 8 in here for h. See the 8? And then they solved just to check it. That's it. And that's all we're going to be doing. That's all you're doing all throughout this. So let's just go ahead and get started. We've got, looks like she just has you guys going into the start here, this just solving these. I guess this is independent practice, okay? Wait, let me pause this here. Okay, what's going on is this is a little bit out of order is what it looks like. Looks like it's a little out of order. It's not really the skill that we were working on. So let's work through these together. They're still going to use algebra skills, and then we'll continue on with solving equations. Okay, so this is part of expressions and equations. So basically what we're going to do here, it says use the properties of operations to write equivalent expressions. Okay, all you're doing is you're just using, like, it's like a video game. You just use the rules or cheats. Use the rules or cheats, you know, like you're playing a game and you know, if you hit the X button, I don't know, it jumps, or if you hit the back button, it does something else on your game. So these are just rules that algebra follows. Okay, that's all they are. Just think of it like kind of like a video game. All right, so you've got 15, and And then you've got in parentheses 5x plus 3 and 2/10, and then you've got minus all this stuff, okay? And all we're going to do is just kind of basically, you got 5x and you have 16x, so it just works better if you combine all the like terms together. It's kind of what we're doing here, making it simpler. Sometimes you want to combine the like terms, make it simpler. Okay, so that's all we're doing. So 15 on the outside the parentheses, that just means to multiply. So 15 times 5x, okay, so you're not given a whole lot of room over here, but you could sort of multiply 15 times 5, okay, and that's going to be 75. So just multiply that times 5x, 75x. And then you have to multiply 15 also times this thing, because it says multiply by both things inside the parentheses. And that's one of those rules you just got to know. Okay, and then we'll just do 3 and 2/10 like this. We don't have to do that decimal until we're all done at the very end. So 5 times 2, 10. 2 times 1 is 2 and 3. Okay, 3 times 5, 15, 3. So hopefully this is a review. You know how to do all that. And you just look at the decimals. You have one number behind the decimal, so you make sure you do one shift or one number behind the decimal there. Plus 38 minus 16x. Okay, and this could be describing, like this could be something that describes something cool, you know, like maybe something cool in nature that's happening, like the way plants are reproducing or something. That's what these equations actually do. A lot of times they describe some kind of a cool behavior. And you might think, well, that looks hard. Nah, just combine this. Look, let's put the x's together. You have 75, then you have minus 16x. So just put them together, 75, and then take 16 away. Okay, you got 59x. That's how many x's if you put those two terms together. So we have 59x, and then you've got 38, 38 and plus 10. So that's 48. So that's it. So this is an equivalent expression. This is the same as this. It's just shorter and neater. And sometimes in math you got to be able to do it both ways. Sometimes you want to be able to do this one like in number 11. You just got to have, again, like playing a video game. Sometimes you take the shortcut. Sometimes, you know, whoops, I got to do something different here. So that's all we're going to do. Let's keep rolling here. Let's keep rolling. All right, we've got this term, same concept. This times this. It's on the outside of the parentheses, times this, and let's combine them. All right, so over here, 12, and then times 12 times 5, or decimal 5, is going to be 60. And you have one number behind the decimal, so that's one number behind the decimal there. So that's going to be 6, excuse me, 6z minus, and you have 0.5 times 7. So that's 7 times 5 is 35. One number behind the decimal, minus 3 and 5/10. And now we'll copy the rest of this, 3 and 5/10 z plus 3 and 5/10. They have a lot of 3 and 5/10 in there. Okay. So let's combine those like terms again. We've got 6z and then minus 3 and 5/10 z. So let's do 6. Now we're going to subtract, so we have to keep that decimal. I'm going to put a decimal in there. And we've got 3 and 5/10. We're going to subtract. Okay. Different than multiplying, right? Because, you know, in multiplying, you're making copies of stuff, and you can just do the decimal at the end. But here, you know, you've got to make sure this is perfect. Okay, so we have 2 and 5/10 z. And now you have minus 3 and 5/10 plus 3 and 5/10. So you've got, there's where you got to have your knowledge of your integers, right? So if you're on, just think of a number line. So if you're on a number line and you start over here at minus 3 and 5/10 and you go up, right, plus 3 and 5/10, that just gets you to 0. So this is all you do, plus 0. And that's what I just put these two terms together. You're going to have to think of a number line on that one. All right, here we go. Here we go. We're rolling. All right, let's go to the next one here. Let's pick something else, kind of an orange. All right, we have 1/4 times 20 and then 1/4 times 10. Okay, so I'm going to 1/4 times 20, so 1/4 times 20. Okay, easiest way to do that is to say, well, let's do, and you could do it over 1, but it's really just 1 times 20 over 4 times 1. Okay, which is the same as 20 over 4, which equals 5. If you think of it, if you have 20 pieces of pizza and you have 1/4 of those, that would give you 5. So we're going to put 5z here. Okay, then our next one is 1/4 times 10. Okay, so we do 1/4 times 10. 1/4 times 10 is going to be the same thing, 10 over 1. So we can just say it's the same as 1 times 10, which is 10 over 4. And so for right now, oh, and then look, we're going to be combining it with this. So let's change this now into a mixed number. All right, so 10 divided by 4. Well, count by 4. 4, 8, 2 groups of 4. Right? There's 2 groups of 4 in 10. There'd be 2 left over. And of course, this is going to stay the same. Your denominator stays the same. So we have plus 2 2/4. Okay, that's all we did. Now we combine the like terms again, right? Simplify this big guy down here. So let's do the, so we'll do plus 1/2 z, and then I'm just copying the rest of this down here. Okay, now we combine them, right? So we have 5z, we should have done it with a different color maybe, 5z plus 1/2 z. We'll just put those together. That's 5 and 1/2 z. No problems. And we have 2 2/4 and then minus 2 1/4. So 2 wholes and 2/4 of a pizza minus 2 wholes and 1/4. Let's do the wholes first. 2 minus 2, that's 0 whole pizzas. We'll do our parts. 2/4 minus 1/4 is 1/4. So we have 1/4 left. Ta-da! There you go. All right, let's do this last one over here. So t plus 5w plus 4t plus t. So you're just going to combine these t's and w's. So let's do this again. 4 on the outside, and you have to multiply it times both of these. But you know what? Why don't you just, t plus t, well, a couple ways to do that. T plus t is just, that's the same as 4 times 2t, right? T plus t is 2t. So you could do that. And then that's the same as 8t. Or you could do it like we did up before. 4 times t is 4t plus 4t. Okay, you could certainly do that. And then copy the rest across. T plus, oh, I didn't leave enough space. Hold on. T plus 5w. So what are you going to do? Just combine all this stuff together. Super easy. Let's do the t's. T plus t, 4t, and 4t, right? Well, 4 and 4 is 8. And over here, 9, 10. So we have 10t. And then all you have left is plus 5w. So that works just fine. Works great. All right, let's look at the next one here. Determine whether each pair of expressions is equivalent. Write yes or no. Okay. So we're going to have to do 2 separate videos. This whole page is practically a video. Okay, are these two terms, these two expressions? So, so let's do this one on the outside here. 4 times, right? Like we were doing before. 4 times 2k is 8k. And then 4 times 1 is 4 plus 2. Let's look over here. Oh, that's 4l, sorry. Yeah, that's supposed to be an L. I'll do it in black. That's supposed to be 4. It's hard to draw it on my page. Nope, still didn't get it. So hold on here. 4, and then an L. Okay, and that matches up. So yes. Okay. All right, let's come over here. We've got 94M minus. Okay, over here 78 minus 94. Okay, so let's put these. Let's take a look at this. We have 94M. We're minus 87. So this part looks okay right here, 94M minus 87. That matches, okay. Let's go to the next part. This says now take away or subtract 78 and 1/10 P. So they're not doing that. So it's pretty tricky. They use the same numbers. And you might say, well, put these in a different order. Well, okay, let's put them in the same order, but we're still not going to subtract here. If we put them in the same order, we'd have to do this. This would be one term. Then this would be our second term, because those guys go together. We can't just, change the sign that's in front of it, okay? Because it's saying to subtract. And then this would be the third term. It would literally mean plus 78. So you might look at this and say, well, hey, it's all the same numbers. And I think that is going to be tricky. But remember, the math operation goes with that number, or with that term. It's not just 94M. It's minus subtracting 94. And that's where it's going to get us right there. And over here, it's just 78 and 1/10 P. It's plus. And that's where it's going to. So that's a no. Okay, you can stop this tape anytime to do this. Okay, let's take a look at number 7. Are these two the same? So let's do our multiplication. Okay, and now you should stop the tape and do this. Okay, or stop the video and then see how it works out. All right, 7 times 3F. That's 21F plus 7 times 2, 14 minus 9F. Plus, and then you got 3 times 5. Okay, 15. All right, well, we got to combine some things. We're not done here. So we have 21F minus 9F. So what is that going to be? Well, 21 minus 10 would be 11. So this will be one more, because this is, so 21 minus 9 will be 12. So I have 12F. Now I have to look at 14 plus 15 here. So 14, and then I have to have 15. Okay, so 14 and 15, that's 29. So it's close, but it's no. It does not match. Okay, close. Okay, so let's do our last one here. Again, let's do our multiplication. Let's see if these guys are going to match up here. Ooh, and this is a tricky one. Look, you got to multiply it times 3 things inside the parentheses. Okay, 50 times 2, that's 100. We got that. 50 times z, and it's minus. See how that you got to copy that minus sign in front? That's 50z. 50 times a. Remember this, that right on the outside of the parentheses, that tells us to multiply. That's plus 50a. Okay. So does that match over here? We got 100 and 100. That matches. Minus 50z, yep. Plus 50a, yep. That's a yes. Okay. All right, so we got one last one to do on this. So Brian used the distributive property. And by the way, that's what this is up here. Okay, all of this that we saw, that's distributive property. Just means you're putting things inside of parentheses and sort of spreading it out again. That's what that looks like. Okay? Every one that we did up here like that, that was the distributive property. We took it, and then we multiplied it out. You know, you distribute, it's like passing something out. So there's another one. That's the distributive property. We took it, and we said that's 4t plus t. Everything that you saw that we did there was distributive property. When we multiplied it, we used the distributive property. Okay. Brian used the distributive property to determine that 14 times 5x minus 3 minus 9x is equal to this. Is he right? All right, let's go check it out. Let's go 14, and then in parentheses, so times 5x minus 3 minus 9x. Let's use our distributive property. So that means 14 times this, and then 14 times this. Don't forget that minus sign. All right, 14 times 5, so you can work that out. Okay, and you've got 70x, right? So 70x minus 14 times 3, 12, 1, 3 times 1 is 3, 4, 42, minus 9x. We're going to combine those like terms, remember? You can put those guys together, 70x, and then remember it's not just, it's minus 9x. That sign goes with it. So what's 70 minus 9? That's going to be 61x, right? 70 minus 9. And we subtract 42. So Brian's wrong, because Brian put 61x plus 42. So he just didn't follow the sign. He forgot his sign right here. So he was wrong on that. Okay, so this is a little bit of a departure from what this lesson was. So I'm going to stop this one here. And then the next video you'll see we'll go to the we'll go back to solving equations. Okay, so this got a little bit out of order on the packet, looks like, or maybe Mrs. Van Houten had a reason for doing it. I don't know. But for now, we'll just kind of stop it.